Hello everybody and welcome to our webinar about test data management, solving the test data bottleneck. My name is Maarten Urbach and together with my colleague Gary Lead, today we will present and talk to you about how to solve the test data bottleneck. We both work for DATPROF, but before we start, just some small notifications. If you have any questions during this webinar, which you are free to ask, please fill them in the Q&A box, which is present. And we will try to answer all of the questions that you might have after the demonstration that Jerry will give. So at the end of this webinar, we will try to answer most of the questions, if there are any, of course. As I already mentioned, today will be partly a demonstration, but we will be starting with a presentation, and I will talk to you and present to you about what we think about how we can solve the test data bottleneck, and Jerry at the end will present and demonstrate how we are able to do so. We roughly think that it will take us about an hour for the total webinar, so that's about it. So. Once again, thank you everybody and welcome to this webinar about solving the test data bottleneck. My name is Maarten Urbach and together with Jerry we will present to you and talk to you about the test data challenges. But first of all, a small introduction of DATPROF. DATPROF is a software vendor and we are specialized in the test data management challenges we see and test data problems we see at customers. But our goal in general is we try to solve or create the best test data, having the right test data for QA and dev engineers in the right place, in the right environment, at the right moment, at the right time. We do this in this particular case, and we try to help customers with solving their test data management challenges that we see happening every time over and over again at customers. And these challenges can be compliance challenges like GDPR, like PCI, like HIPAA, and we help customers out with these test data management challenges. Also, storage is a common challenge in test data management. We like to store more and more data, but we also should take care of this data, especially if we want to move faster in the software development part. But also collaboration, working together, close together, more teams, this will also affect the test data management challenge. And at the end, understanding what kind of data you need and what kind of data is necessary for testing and development purposes is also one of the challenges we see in many organizations, corporates, that is one of the challenges they face. We solve that with our software products, and we have several software products in the test data management area. One of them is DATPROF Analyze. Analyze helps us and helps our clients out with the discovery or profiling of privacy sensitive data. PI data for that matter, but it's also very effective in finding a specific test data cases in your data source. DATPROF Subset and DATPROF Privacy. DATPROF Privacy is primarily for helping you getting compliant to privacy regulations, the GDPR and the PCI compliancy, for example. DATPROF Subset helps us in extracting pieces of data out of a data source and extract them and filtering them out and put them in your non-prod, your downstream environments for testing and development purposes. And DATPROF Runtime is our execution platform, which helps you out in automatically deploying all the data to the different environments where you may need it. We're pretty proud of the fact that we are only one of the small number of vendors that are able to mask or subset or execute test data management solutions to the most commonly used relational database platform. So we are able to execute it on Oracle, MySQL, DB2, and all the different platforms that you see below. So that's about the introduction of DATPROF. Now we start the real webinar or the real content about solving the test data bottleneck. So today we have a bit of a serious subject, solving the test data bottleneck. and we are trying to figure out what is holding us back in the release process and why test data management can hold us back in the release process. And today we all like to think that software is crucial. And not only software is crucial for automating or speeding up your business processes, but it's also important for your business in general. Because what we see nowadays is that it's a competitive advantage over other organizations in the same market if you have a great IT organizations. Some of the banks, the finances in this world already mentioned that they are more like an IT company than that they are a finance company. So you see a shift also in these areas, that companies becoming more and more aware of that they are more and more an IT company. And because it's a real competitive advantage over other companies, you try to deliver software faster to the market than your competitors will. So that's a bit of a challenge to be the first one to have new features available. And if you are able to do so, then you could be probably king in this market. And that's also the reason why we as DATPROF see, and what we think sometimes see, what happens when customers talk about agile, test automation, service virtualization, DevOps, scrums, whatever you may call it. But in most cases, these changes in organizations are there to speed up the process of the software development to the market in the end. So we see all these kinds of trends and hypes evolving, and this will change organizations. And nowadays, we talk with organizations, and all these these organizations, corporations are working in teams or tribes, if you would like so. And these teams are multidisciplinary. You got software development, software quality engineers, test automation engineers. And some of these teams are even self-regulated, and I really like it. That's really cool. But there is also a problem that we often don't think about, because there is a challenge if you want to implement all these wonderful, important topics in your organizations. Then you also need to think about your infrastructure. And what we see in many cases, that this also, if you want to be able to deliver all these subjects and all these topics on time, you still have a test data bottleneck. You need to think about this test data bottleneck, because what we see is that when there are multiple teams, there is in most cases a limited number of databases. And when you have an agile team and your organization is becoming agile, then you will need also maybe more of these databases, because all of your teams are developing new code and producing new software code and wants to test it, but there's in most cases what we see only one database. Typically what we see is that there's only one test database on maybe 5 to 10 teams, and maybe then you're even lucky. And this is getting a bottleneck, because you're losing valuable time that is important, that you want to produce new software code or you want to go to market faster. So today we have 3 major bottlenecks that I will try to discuss with all of you. The first one is one I already a little bit mentioned, is the fact that there's a limited number of resources compared to the number of teams that you have. So in this case, most cases, there's a limited there are more teams than there are test databases or dev databases available. Another bottleneck that we in most cases see at customers, and which one is one of the subjects that we try to discuss, is that we find out that and research telling us that a lot of software testing, software quality time is lost. 50%, but sometimes even 75% is lost by searching and finding the right test data. And the last bottleneck that we try to discuss today is that you want to be able to rely on your test data. So you want to make sure that if you test a piece of software code, that it's if a fault occurs, it's really a fault in the software code and not in the test data. So you want to rely on your test data. So let us take at first a close look at the first bottleneck. Multiple teams on a limited number of databases. The question arises, in our opinion, which you also should take care of, is why is it the fact that we have a limited number of databases compared to the number of teams that we have? Well, what we see and what's pretty logical, especially in the corporate world, is that most core systems that are built nowadays or are still used nowadays are built upon Oracle, SQL Server, or even DB2. And sometimes right now you see databases that are used that are MySQL or Postgres, but in most cases in corporate organizations you will see that systems are built based upon Microsoft, Oracle, or SQL Server. And in these specific areas, it's fair to say that the larger the database is, the larger the cost. So the size in these specific areas do count. Large is in most cases important because you will be charged based upon the size of your database. In some cases, it's really based upon the number of gigabytes or terabytes that you store, but you also see some database vendors that charge you based upon the number of CPUs that you need for a great performance or a better performance. But that number of CPUs is already related, of course, to the size of your production database. So size does matter. But it's also impacting the size of your core system. It's also impacting all your downstream environments. If you make copies of these environments to the different downstream environment, your acceptance, your QA, or your dev environment, this can be quite costly. From a license perspective, of course, because you need to have a database license server up and ready and paid, but also from a storage perspective. Maybe even, especially when you move to the cloud. So the main reason why we see that not every team has its own database is in most cases purely based on cost. But not every database vendor is charging you based upon the number of instances you have. So if you can have these instances, but in most cases the cost, it's cost driven based upon the size that you store in your core systems or in your system itself, your database itself. So what we see, back again, what's happened if you have a team and you have a limited number of teams, organizations, corporates try to solve it. And what we see, what happens in most cases is, well, it's something I like to call maybe survival of the fittest. If one of your teams find the test data, your specific test cases first, you can execute your test first. So the other teams have a bit of a pity because they should search for another test case or test data case. But if you are the first one to find the right test case, you're king. That's one of the things that we see happening when you take a look at how they are organizing themselves. Another way that customers, clients also organize themselves is by something we could call planning. You might say team 1 has the availability of the dev environment in week 2, and team 2 has the availability of the QA environment in week 2 and 3, and you can go on. But if you take a closer look to this picture, this ain't agile anymore. This is something prehistorical. This is something we had from the past. It's almost looking like a waterfall project. And this is not something you would like to have. This ain't working. This is a bit of the bottleneck that you need to solve if you want to move faster to the market. That's the first bottleneck that we in most cases see at customers. The other bottleneck that I mentioned at first is that it takes a lot of time to search and find the right test cases or finding the right test data. I think from a QA and dev perspective, it's important to have the right test case coverage, because if you have a right test case coverage, you are pretty sure that if you, or at least you have a bit of understanding that if you go to production, you have software from the right level of quality that you might expect because you had the right test case coverage. But you also need to have an understanding on your test data coverage. And especially in large databases, what we see, it's quite challenging to find these specific test data cases based upon your test case coverage. And especially in what we see happening in more complex environments is getting even more challenging. Because what we see in corporates and in older databases, maybe you have a database that's even 30, 50 years old. And in these systems, there's quite a number of data stored. Maybe history data, maybe even data that is migrated once or maybe even twice. And these test cases or test data cases are quite interesting if you want to test with the right quality. So getting the right test case coverage for your customer that just joined you yesterday is maybe quite easy to find. But you want to have the same expectations, or you want to have the same expectation. The customer wants to have the same expectation if they already joined your company 30 years ago. So what you need the right test case coverage. And this can be quite challenging, especially if you still use full-size copies of a database. We sometimes see databases that are really large, sometimes with a complex data model. And I'm just showing you a bit of a simple part of a complex data model, because in most cases these data models can be even larger. Sometimes we encounter 5,000 tables or 10,000 tables. But also the size doesn't matter. If you have a database with 30 terabytes, it can be quite challenging finding the right test cases. So we don't wonder why it's so challenging, why so much time is lost for searching the right test data, searching and finding the right test data. And what's also really a pity that if you found the right test data and you have limited resources available, then it can still be the case that another team manipulated the test data that you just found just before you, because you're still all working on the same database. The last bottleneck that I would like to mention is, I sometimes call it test data management, but it's really how you manage your test data. Because I think what's really important is that you want to rely on your test data. And what we see happening in most cases is that as a software quality engineer, as a software development engineer, you're not always sure that if you find a fault in your test report, that it's really a fault in the software code. It could also be a fault in your test data. So there can be some false positives. And what we see is that in most cases, you work with two unknowns. You don't always sure if it's a fault in the code or if it's a fault in the test data. And if you were able to rely on your test data, then you could give better feedback to your team, to your dev engineers. And if you give better feedback, then you can create better code. And if you can create better code, you can go faster to production. Well, these are specifically the bottlenecks that we try to mention. And these are the bottlenecks that we in most cases see happening at customers. And what's the challenge is nowadays, especially nowadays with CI/CD and DevOps, is that we are trying to go to production every day. At least that's what we're aiming for. We try to add new features every day to our software. And I sometimes like to mention that we try to build Rome every day. But if we're not really sure if we press compile due to the fact that we have maybe the wrong test data, then instead of building Rome, we could also end up with Los Angeles or Amsterdam or London. We don't know. So if we want to make sure that we have the right test data, or if we still want to build Rome every day, we need to make sure that we get hold of our test data. So how to solve? And this is maybe interesting. And after this part, Jerry will take over in the demonstration. But I think most of you will recognize some of these bottlenecks. Maybe you have a little bit different bottleneck. This can be even more challenging when you have multiple bottlenecks, but I hope most of you recognize the bottlenecks that I just mentioned. if we start discussing these challenges with our customers, in most cases we like to improve two major things, and I like to call it speed and controllability. Speed meaning we want to make sure that we give QA and dev engineers easy access and easy availability of their test data. And controllability means, in my case, that you want to be able to rely on your test data. And there are a couple ways that how we solve these challenges with our customers. To start off, of course, what we see, customers have a production environment, which is perfectly fine, of course, which we all probably have, otherwise we wouldn't be here. But for this solution, in this architecture that I'm telling you right now, we like to make, in most cases, a copy of that production environment. And this is a real simple concept, and I understand that in real life it's way more complex, but this is really a concept how you could think about it. And this could be more complex when you really dive into it, but maybe that's a little bit too much for now. But you would want to create a real life or a copy of a production. This database could even be a little bit less in size. It should not always be 100% copy, but at least you would have a copy of this production environment. Why we want this? For now, I called it the master test data management environment, but you could also call it master test environment or master whatever it may be. But what's interesting about this master TDM environment in the end is that you have a point of return. If some of the tests went wrong or some of the data that you used were already manipulated, you can also always go back to the latest point of return, and that's your master TDM environment or your master test environment, which is quite interesting. Of course, due to the very good privacy regulations we have nowadays, you should depersonalize this environment. That's at least what we try to advise our clients. Depersonalize it using masking techniques, using synthetic test data techniques, and also Jerry will show you some of these techniques during the demonstration, how you could make sure that this environment is depersonalized and compliant to the different privacy regulations there might be. And if you have masked this environment, we like to use subsets and deploy subsets to the further downstream environments. So this can be rather maybe a little bit more costly, but this is really cost effective because you are able to deploy smaller subsets of your master TDM environment to your downstream dev QA or maybe a test automation environment that you want. The wonderful thing is, because most vendors, database vendors, aren't charging you based upon the number of instances you have, but purely based upon the size it is, these environments can be quite less expensive in the end. And that's the reason why you can deploy many of these to the different teams, which already solves one of the first bottlenecks that I mentioned, is that what you want is that every team has its own small database that they can influence, which they know for sure what kind of data is present, but it's purely in size. So you don't have any challenges with working together with your team or other teams, especially in an agile environment where multiple teams try to execute as many tests as they can. The other real important thing is, and that's also interesting, if you have these environments available with the help of the subset, you're quite aware of what kind of data is present in your environment. And what's interesting is that's the second one, the finding and searching for the right test data. This may take time for the initial run, but after you recognized and discovered which specific test data you need, with the help of subsets, we're able to create always the same subsets to put them in these environments. So you can reuse the same subset over again. And even after you manipulated it, you can still go to this last point of return and execute the same subset, and you will end up with the same subset. So you can execute for regression tests over and over again the same test data, even after it's manipulated. And the last bottleneck is also solved with this architecture, because right now you can really rely on your test data, because before you're not always sure what kind of data was present, but right now you're able to really rely on your test data, because you know for sure that if you execute it multiple times, that you have exactly the same starting point as you had before you executed the same test. So if you take a closer look, and this is also what Jerry will demonstrate in a minute, because I'm almost finished. And it's also what Jerry will show you during his demonstration. He will try to create a master TDM environment, and he will deploy the different subset to the QA environment, which helps you in solving the test data bottleneck. So right now I want to hand over the floor to Jerry, and I will send some things. So I have to do some small things to make sure you're able to see what Jerry wants to present. So.
Thanks very much, Martin.
You're welcome. And I will.
I'm about to share, and all being well, people can see my screen now.
Yes.
As he says, all being well. Ladies and gentlemen, thanks for joining us today. As Martin says, my name is Jerry Leith, and my background is one of having only 16 years ago masked my first database and created a referentially intact subset of it. So I have the scars on my back with a number of different client cases, and I've also had some very good success as well, obviously. The picture that you see at the moment actually follows on from Martin's description of the copy of a production database. Typically, you would hold production level security against it until such time as you've masked or obfuscated or scrambled, whatever words you want to use, and then you would deploy it downstream to dev, test, train, QA. And in some instances, there may be several copies of any one database at any one time. So this is the kind of architecture that we start with, but it's a good foundation, because if you take Martin's point that the QA and the dev environments become subsets, then you are really removing bottlenecks, because they all sit in isolation. The production clearly is on its own, but the data masked, test data master, gold copy, whatever you want to call it, sits in isolation, and these are deployed from it, and that's what we'll do. In fact, within about a half an hour, if I get my skates on, we will start with a database. We will mask it, we will create a subset from it, and we will tuck it underneath the runtime framework, so I can show you all aspects of the test data management suite. This particular document, which is open, is in fact a masking plan, project plan. And it's a good foundation which we'll deliver to you after this webinar, which sets the stage for the first part of test data management, which is about the anonymization of the data in accordance with compliance GDPR. Recital 26 of the General Data Protection Regulations say that if you have anonymized your database, it no longer falls within GDPR. And it's something that people don't realize, that simply anonymizing it, and anonymizing it properly, obviously, really just removes the whole concept of GDPR away from your downstream environments. This document also covers other aspects, such as the masking plan itself, which is normally informed by your data inventory. Again, GDPR says that you should have an inventory of where your personally identifiable or protected health information is. And this is the foundation for a plan. And that plan really does map itself against your data. So from this point on, we're going to be working live and hot. We're going to build ourselves a masking project. We're going to build ourselves a subsetting project, and we're going to fetch it under the realms of the runtime environment, which is the framework under which we execute or can call the masking and subsetting projects. So what we'll be doing actually is we'll do it now. We'll create ourselves a project, and we'll call it Jerry. And this is our foundation now. We're going to be adding environments ultimately, our connections to our environments. I'll do that later on. And we'll then add in our projects, and you can see how it all works live. But really, we start with this concept of the masking plan, which is identifying personally identifiable items within our database, that which identifies a natural person. So it's who are you? What's your name? What's your date of birth? What's your national identification number? Where do you live? How do I contact you? What do I know about you? Criminal records, court orders and attachments, for instance, gender identity, sexual preference, disabilities, all of these things that we come to know about people, we identify those and they inform the masking plan, which I showed you earlier on. But we can build a plan here now. We know we can see a first name and a last name, and the last names have been uppered, and the last name's part of the email address, and there's a date of birth and so on. So we can choose some of these just to affect our masking plan. Suffice to say, what we need to do is to mask a database in such a way that it looks credible, usable, that it smells, feels, touches, tastes, just like the real database. Because if we don't, then the user of the database will question the data before they question what they did to it. And that's a critical part of delivering a sensibly masked database. So if you follow my masking plan now, what we'll do is we'll change the first name and the last name, and we'll change the email address. We'll just resynchronize that. We'll leave the upper last name because that will give us an idea of what it was before. However, this environment also has a test and a test 2 and a test 3. And so test, if we look at test here right now, customers, we'll get ourselves logged in and have a look at test again. It's exactly the same as the production environment. So they are identical, full size. Now, one quick war story before we get started. Before I joined DATPROF last year, I did a masking project with a client who had a fairly large database with an audit table that was 500 gigabytes in size. And that database was deployed 8 ways downstream. So follow it, 4 terabytes of audit data. When you start to do masking projects, you look at things like this. You look at where the space is being used, not just for masking purposes, because it takes time, obviously, to mask a table, but also for the subsetting process as well. So if you think about it, things like audit tables tend to take a lot of space and they don't get used. And in that particular case, one of the first things I did was a simple truncate statement and removed it from the environment, just truncated it. Nobody noticed. So things like this you look at when you're building your masking plan, and what we'll be doing therefore is we'll get ourselves connected to the database using the privacy module. Now, privacy is a project-driven environment, and as I promised, we're going to start from the beginning and we're going to create ourselves a new masking project. We'll connect ourselves to the database. In this case, it's this one, which is behind us there, the prod2. So we'll get ourselves onto that quick test just to make sure all is well, and we'll use it. Now we need to know, understandably, we need to know about the table structures and we need to know about the constraints. These are all important to us because it's quite possible to mask a constrained item like a primary key. So clearly we need to know all of this. And in just those few brief actions, I now know all about the database, the tables within it. Clearly this is a smallish one. It needs to be for demo purposes. And I can then start to apply my masking plan very quickly, just by choosing the driver table, in this case, the customers, and choosing the item which I want to affect my first masking rule on, and adding functions which will do something. Now, there is a standard set, obviously, of things that you can and should do when you're masking a database. Very often, it's possible to just blank the data, null it. You don't need to see it. It can go. I don't care. Or you might choose to scramble it or redact it, if you will. So keep the format the same, just X and 9 it. That has its place as well. Sometimes your own data is the best replacement candidates. So a shuffle comes into play. Shuffles are dead easy to instrument. You simply say shuffle, choose the columns that you want to shuffle perhaps in concert with each other. So the two columns, last name and last name upper, could randomly move from one row to another, and just say OK. And that's your first rule built, as simple as that. In this case, I don't want to do that. I'm actually going to show you something else. What we'll do is we'll have a look at the first name, and we'll create a function which is going to generate replacement values on a like-for-like basis. You may recall me saying that what we want to do is to result something which looks, feels, smells, touch, tastes just like the real database. And this is how we do it. We choose ourselves a replacement data set, like first name's female, and we'll choose a language pack for it, US English, Swedish, Dutch, French. Here's the thing, you can add your own. These are extensible. You can change these if you want to. Put simply, they're comma separated value files, which live within our installation directory, this seeds directory, if you will, and we can add to them. We can add our own. So that's what appears in this list here. We'll choose the US English list for now. Now, when we're masking a database, we want consistency around the database. We want consistency arguably across the platforms as well, because I may have a MySQL front-end database which mirrors an Oracle database in the back end. And if I'm masking the two independently, which you tend to do, you want to result in the same values. So Lynn, for instance, will always become Denise in a scenario like this. And that's what our concept of deterministic masking delivers. Think of it as consistent masking across the estate. Any of the database platforms which we support, Oracle, Sybase, Oracle SQL Server, DB2, MariaDB, MySQL, Postgres, and so on, we can result in a consistently masked database across all of those platforms. I'm just going to use the US one for now. Okay, now conditional masking is something that people ask as well. I only want to mask it in this particular scenario. So where gender, for instance, equals female, we will put a female first name. That's a good test function here. Make sure we know what we're dealing with. We'll put a female first name into this set deterministically, and we say, OK, if I use this rule on any other table, in any database, on any other platforms, it will result in Lynn always becoming Denise. Now, obviously, that does where the gender is female. We also need to do where the gender is male. So we'll clone the rule, nice and easy, and we'll quickly change our selection criteria to male to use the US English set deterministically, and the condition becomes male. And we'll do a test again. So we've now changed the first names. And we've done two rules, and it's not taken us too long to do. One of the comments that our clients make to us is that this software is extremely easy to adopt. It's intuitive. It does what you think it will do. You click on an item, you use the right mouse button, and you can then drive yourself into whatever function it may be. In this case, we'll generate a new last name, and we use the same language packs again. And deterministic, again, wherever we see this last name on any table, any database, any platform, it will be consistently changed from Leaf to Smith. And we don't need a where clause on that at all. So you see how the picture comes together. You implement your masking plan. I promise you we'd also change the email address as well, which we'll do because this is it uses one of the other functions. It's a custom sort of expression where we would probably create the email address based upon like a first initial dot last name at something.com, like that. So if I test that one, it validates OK, right? My SQL statements are in place. You may have noticed I used a hotkey copy and paste on there because it would have taken me about 10 minutes to type that in real life. We have no conditions that we need to worry about or anything like that. However, we do need to stop and think about what we're doing from time to time, because this actually does require the successful masking of the first name and the last name before this can actually occur. Otherwise, we might end up creating a new email address with unmasked data. In other words, there's a sequence of events. In other words, there's a scheduler that controls the operation of the process. And to that extent, we have to instrument dependencies. Now, dependencies are this one must run before that one can run, or these must run after that one has run, in a nutshell. And it doesn't take long to get that process in your mind. So what this says is, if I use the dependencies editor, this one, and this one must all run before that one can. And there we go. So that's going to recreate the email address for me after the names have been changed. So we'll OK on that. And that's achieved what we want to do from a masking perspective so far. Clearly, there are other tables that would contain masked or data which needs to be masked. You would simply move through your masking plan, and ultimately you'll get to the point where you're ready to run it. And from a deployment perspective, there's a couple of things we need to think about. The first one of them is, how long does it take? Those are the questions we get asked. How long does it take to mask a 50 terabyte database, for instance? The answer to that question centers upon not just the size of the whole database, but it's about the tables that contain data which should be masked. So typically we look at the row counts of those, and they tend not to be that large in real terms. Yes, sometimes some of our customers, for instance, one of them has a 13 billion row table which he masks. So yeah, it can be big at times. So there's an element of parallelism that we can implement into the masking process using these parallel processes here. That's why we need to think about the concept dependencies, because if we look at the way the process is going to work, we'll see that certain things must happen before others. So the parallelism is implemented and visualized here. And we'll look at visualization a bit later on when we go and have a look at subsetting a database as well. So what we're going to do is we're going to set it off in its way, start it, and from this point on, the data is going to be updated in situ, static data masking. It's going to replace it. It's irreversible. There's no way back from this point. While we're doing that, let's think about that runtime module that we had a look at, because ultimately, once that's done, we'll want to tuck it under Jerry. So we'll add ourselves an environment now, which is Jerry Mask, let's say, which is the name of that project that we've done. It is an Oracle database, so these are the other ones again that we support. And the IP address is 192.168.56.101. That's my local VM. And the user is tdg_prod. And our user is admin. There you go, I'm giving away the password. And it's an XC service. So this is us now folding this. Invalid username, password, log on to tdg_prod. tdg_prod_2 is probably what it should be. So let's test that. There we go. So we've now got this environment ready for us to fetch in our masking project. Now the masking project itself is now completed. If we look at the logging concepts, we can create an audit report that says this is what we've done. These are the row counts. It's finished. This is how long it took. This is the document we hand to ISO, CISO, CIO, Chief Data Officer to say our environment is now secure. It is masked. And when it comes to actually automating the process in the future, we deploy the project to runtime by simply generating it for runtime and saying generate. This creates a zip package of all of the things that we need to affect that masking project, Jerry Mask. So if I fetch it now back to the runtime environment and I go to Jerry Mask, I can install an application here, which is the one I've just created. We'll have a quick browse, and it's in our documents and in DATPROF, privacy, and Jerry Mask. There he is, and it's in there. So I'll now upload that, and that is ready to be called at any time by anybody logging into this runtime service on a self-service basis, or it can be API called by tools like Jenkins or Bamboo or job management systems like BMC's Control-N, for instance. It can be called under script or API direct control. It's ready to go. If I press mask, that database will be masked again. But that's going to confuse us a little bit, because what we want to see is what the difference is in the data itself. And what we have now is Raoul Lassiter, and you'll see we intentionally left the name as Fenner, and it's r.lassiter@testdata.com, exactly what we wanted. The database has been masked. We've proven it along the way. We've saved it as a project which can be reused against other databases of the same content structure, if you will, and we're good to go. The second part of getting rid of that bottleneck, as we looked at in the picture that said we have our gold test data masker, and now we're deploying it downstream, is the creation of a subset. Now, subsets tend to be sprint specific. We'll create ourselves a new project here, and we'll call it Jerry, correctly spelled Jerry underscore subset. And we're going to tuck that ultimately underneath that same runtime environment where we can call it interactively or through API calls. Subsets always start with the answer to a question. What do you want? Well, I want data from a source environment. This is our now masked gold copy. And I want to put it into something. This is our target. This is the sprint specific environment, in this case, TDG test. We'll just test that to make sure we're on it. There we go. And under Oracle, we use a concept called a database link, because what we'll be doing is drawing the data from the source database, the one we've masked, our gold test data master, and we'll be fetching it into this lower environment. And we'll make a choice. We'll answer the question, what do you want? Because that's what the sprint has to answer. So let's go and get our structures here. And next, I could easily have pulled this in from the masking project, actually. But as you see, it's very straightforward and easy to do. All I really need to do now is to specify the target schema on the destination side, the subset, and I'm ready to go. So answer the question, what do you want? Well, let's have a look at the data. This now newly masked data has got Lauser, Bueno, E, P, G, H, C, B, G, G. There's a couple of G's in there. So what we'll do is we'll say, okay, we're going to find everything that starts with a G. I know it's a notional thing to request, but it could just as easily be a sprint saying, I want the customers in this list, or I want all of the customers who have an inception date of the last quarter, or transactions which are in the last 6 months, for instance. They form the foundation of that question, what do you want? And that's what we need to do when we're thinking about creating subsets of databases, is establish what the driver is. What do we want? And in this case, we're coming off the customer table, not currency, customer. And we will give ourselves a where clause effectively. Now it can be as complex as any where clause can be, but in this case, we're going to keep it simple. We'll say where last underscore name, like G is what we said, %. So we should see those couple of G's, the Garths and so on in there. So once we have this driver, we then need to make a decision about all these other tables and what we want from them. And it's a daunting task. Please don't let anybody ever tell you that creating a referentially intact subset is trivial, because it is not. There's work to be done in the process, but what we try and do is make it as easy as possible. Clearly, it won't be as easy as I'm about to do right now, but the approach and the techniques that I'm using make it simpler. We normally start with understanding how many rows are in the table and sorting them by the row counts. The bigger the tables, the more likely they are to be subset candidates. And what we basically end up doing is filling these. That one doesn't belong there. I'll just pop that one back to there. Okay, what we end up doing is filling these with, I don't care. I don't need this data. And that's a viable thing to have as well. This table can be empty. This table can be full because, for instance, it might be a reference table of some sort. And in fact, remember we had a look at the visualize for the process model and the privacy side of things. We can see the data model here. And granted, this is a simplistic database, but this gives us an indication of the kind of environments, things that we see. We see, for instance, our driver table here is related to others. So it follows that I would expect to get those rows from those tables where there is a relationship by default if it's a subset. Some of the tables on the outside here, the outside of the loops, they can exist without the presence of another table or other rows in another table. So they can effectively be pulled in full. Typically, these are reference tables. So in this case, it's our currency table. Down here, it's our supplier contacts, which is only a small table anyway, and our supplier products. So technically, these could all be pulled in and they wouldn't cause an explosion, which is one of the things you have to be aware of when you're creating a subset, is that you don't choose something that means the only thing that can resolve is the whole database. So we have these thoughts and processes going through our minds. We have relationships, we have tables that are on the outside of things. And what that means is we can put a little bit of intelligence into a suggestion mechanism that says, tell me what you think I should do. And this can save you a lot of time. And what this says is, based upon your driver, you can actually create subsets of all of these. Looking at things like the row counts, because there's not that many, you can probably safely fetch all these in and you won't explode the environment. So what we'll do is we'll adopt the suggestion. And this is your good first start point. Now, sometimes you may say, okay, I don't know about all of these. Do I really need them or not? And yes, there are ways to apply additional filters, for instance, to say, okay, only give me, let's say, these transactions for the last quarter. So we can refine the subset using additional filters, for instance. But just for now, this has got me started. This has got me where I want to be. I know I'm going to get referentially intact subsets of all of these guys, and I'll be quite happy with that. So I'll be saving this away. Obviously, I'll save that project as we go along. If I were to visualize a process model with this now, and again, bear in mind that it runs the same way in the same concept as the privacy module, that we try and get some degree of parallelism going. So all the falls will happen all concurrently, and this will run side by side. This one will fetch all of those rows in customer history that it needs. It will fetch all of those in contracts and fetch those in orders. Contracts will fetch the details and the tasks that it needs. Orders will fetch the tasks that it needs. So it's resolving everything for us as we go along. And very often, this is the best start point for a subset. And in following this practice, you can get your first subset by simply saying deploy and start, and it will send it off on its way. Now, there are a variety of options available to us. Most of the time, thinking about the fact that I've got my own little database and I just broke it, I need to refill it. I need to recreate it. So this would be one of your self-service options, for instance, where you can say refill. You could equally say, okay, I want to pick up what's new in the test data master. I can delta load that which I don't already have. And that's often asked for as well. But in our case, we'll just send it off to refill, and it's now going to go away, and it will draw all the data from that first database, the one that we've masked, and it will place it into our smaller TDG test database. So while that's happening, we'll generate this for runtime as well. So that's me speaking with some confidence. Obviously, Jerry's subset will now be available to us to put into the runtime environment while that's running. So we'll do that. We'll get ourselves into runtime and into Jerry, and we'll add ourselves a new environment, which is now going to be Jerry the score subset, and that's an Oracle database. Again, is 192.168.56.101, and it's on 1521. This time though, it's TDG test. This is our target schema. And our password is okay there, and we'll test it. Okay, so we're good to go. We now have our second environment. And all this now needs me to do is to install the application which we just created, which is the DATPROF subset, Jerry subset, that one. and that's now ready to be called through the self-service module. We can recreate, refill, whatever we need to do. And it's as easy as that to fetch it into this environment. Now, that database should by now be just about, and it's subsetted. So we'll go and have a quick look at it, look at the data itself. Here is our source. This is TDG prod 2. It's our masked gold copy. And if we go and have a look at the test environment now, we'll see they all start with G, which is what I requested. We now have a smaller, far more agile environment to work with. We can break it if we wish. If things go all badly wrong, then what we can do is we can get ourselves into the runtime environment. We can go to the Jerry subset again, and we can simply say refill, and it will go off and it will start the process once more, and it will refill that database for me. I have no bottlenecks in the way. I can do it myself. Don't have to wait for DBA. Don't have to wait for any resources. Away we go from there. Now, the good thing about the runtime module, as I mentioned, it also they can be controlled by API or called from a PowerShell script, for instance, but it also gives us all of the history of our execution as well. So we can go back and have a look at it. We can find out if something's gone wrong, which normally it wouldn't do, but I think you get the point there. We can also instrument triggers on any actions that are happening during the runtime deployment. So we could say, for instance, that when it's running, if there's an error, I want you to, for instance, send an email and notify me of it. So that the entire framework is there to help us make sure that we get the right test data that we want to the right place and at the right time. And now what we should see, it shouldn't be too long. If we go and have a look at the monitor context, it's finished already. If we have a look at the run history, there's the one that we just done, and everything is successful. And if we have a look at the audit report for it, this is the one that we hand over again, if we need to CIO, CISO, that says we now have a referentially intact subset driven from the mass database, and look how much smaller it is. And I think I managed to do that in less than 30 minutes. So in summary, again, what we've got is a solution where we can create the rules that we need to make sure that we achieve regulatory compliance. We can deploy that out to the runtime environment to make it easy to call, easy to run. And we can also then subsequently, we can generate ourselves a subset quite quickly, relatively easily, but again, take the point that I made that it's not always trivial, but this gets us a good start in reducing the footprint of the downstream databases so we can have more of them that match the requirements of the sprint. And Martin, that's me. I'm talked out, I think.
Wonderful, Jerry.
I'll stop sharing now.
Okay. That's perfect. Then I will drop this one over here. And what I want to show them, everybody, at the end, let me do some last things. That's this one. I want this one. And now I'm sending the things live. The last thing that we wanted to share, and that in the end, this is something what we typically what we ended up with. We started the presentation with, we really think that if you're able to solve these bottlenecks, then we're able to, instead of the test data is a bottleneck, it could be also be an accelerator for all the projects that you are implementing or trying to execute. Well, that at least was our webinar and our presentation and our demonstration. I will now take a closer look at some of the questions. Let me take a look. We have several questions. I will publish 2 of them. So there's one question that can we mask in the same database where the data resides, and also we can pick the data from source or prod and mask it before loading it into the target. Well, I think maybe Jerry and I can answer this question, but what we typically do is we mask it in place. So if you have a database with test data or data inside of it, we will do it in the same database. So the data resides in this particular case inside the same database. The second one is a little bit, in my perspective, in contrast with the first part. So picking up data from a source, when you're delivering it to the target environment, then mask it. Then you should do it on the fly or something like that. That's possible when you think about XML messages, for example. We do it a little bit differently than what Jerry told you or showed you now, but I think that's a little bit differently. So at least the first part, that's something what we typically do with DATPROF privacy. Am I right, Jerry?
Yeah, that's right. And Abhishek, just looking at your question there, we don't typically we don't mask data on the fly in flight from source to the downstream environment. Typically, you would take a copy of the source, hold production level security against it until such time as you've masked it, and then you send it down to the further lower environments. You also mentioned or asked the question about whether you can effectively impose your own application inferred constraints, because as you rightly will have seen, I used all of the constraints in the database to get those contract details and customer history and so on. Not all environments have the database relationships defined in the RI. Very often they can be at the application level, in which case, yes, you can define within the tool, and in fact it's in both tools, the subset and also in the privacy module. You can define those relationships, what are effectively virtual foreign keys. They don't become foreign keys in the database, but you can define those relationships, and it will pull the data based upon what you define as the relationship, not just that which is implied within the referential model.
Thanks. I hope this answered the question. I had one last question, Jerry. Maybe you can help. That someone other asked it to me. But what about the cloud? What about Azure or AWS? Is that also part of the DATPROF suite?
And the answer to that is yes, it is. It's actually quite transparent to us. You can install our solutions on, for instance, an EC2 platform, and you can touch any database which your client connect string will allow you to connect to, based upon obviously permissions and network permissions and so on. So it's entirely transparent. You can be on-prem, you can be in cloud, and you can be hybrid. You can do them all.
Cool. Okay, I will take a close look then again to the questions if there are any. Doesn't really look like that there are any questions left for now. So if there aren't any questions left, then I would like to thank everybody for joining this webinar and being there. And I hope it answered most of your questions and how you could solve the test data bottleneck. As Jerry mentioned, we will send the data masking project plan afterwards to everybody that registered for this webinar. And then I hope you enjoyed it, and I wish you a wonderful day. So thank you very much.
And from me, thank you as well.
Perfect. Thank you. Bye-bye.